everybody. I hope you're doing well and welcome to the platform of CodeChef. So today we're gonna be solving the problem Queen's Necklace. The difficulty level for this problem is simple and the prerequisites require are your basic hashmap data structure. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, let us try to understand the problem statement. Fields was very busy because of some work, and he could not give much time to his queen, because of which she was angry. To make her happy, the king decided to make a necklace of pearls for her. The king buys an array A of n pearls, where ith element represents the type of pearl. Since he loves her a lot, he knows that she will like the necklace if and only if each type of pearl is present in the necklace in a unique quantity. Can you tell if the queen will like the necklace? Okay, so basically in this question, it is given that I am given an array of n lengths, and then each of my array element ai is a necklace of type. So basically in the sample test, as you can see, this necklace is a type 3, this necklace is of type 4, and this necklace is of type 1, or it is made up of type of pearl of type 1, right? So this is what the question is saying. So the question is saying basically that the queen will like only if this type of pearl present in the necklace is a unique quantity. So as you can see in this particular case, my 3 type of pearl is occurring 2 times, my 1 type of pearl is occurring 2 times, and my 4 type of pearl is occurring 1 time, right? So basically, both of the pearls of type 3 and type 1 occur 2 times, which is not distinct, and hence the queen will not like this particular necklace. Now let us compute the other test case. As you can see, the type 4 is occurring 3 times, my type 5 is occurring 1 time, and my type 8 is occurring 2 times. So each type of unique number of times because my 3, 1 and 2 are unique. But in above case my 2 and 2 were same, and hence in the first test case the answer was no, but in the second test case since my values are unique my answer is yes. And this is what the question is asking. Now let us see how we can approach this particular problem. So in order to approach this problem, what we can do is, firstly we can use the map data structure. My map data structure can be easily used to calculate the frequencies of each and every element, right? So the goal of this question is nothing but we have to check whether the frequencies or the values of the particular elements or the types are distinct or not. So if all of them are distinct, then my answer is yes, otherwise my answer is no. So we can just use my hash map in order to compute the frequency of each and every element. Once I computed frequencies of each and every element, what I can do is I can make a vector of all those values of that particular frequencies, and what I can do is I can simply sort my vector. So what will happening after sorting the vector is if there are adjacent values, say in this particular case my vector will comprise of 1, 2, 2. So as you can see, if by sorting the vector what I do is I can simply compare my adjacent values, and if any two adjacent values is same, then that means then that particular vector or that particular element in those vector is not unique. So yeah, we can just sort the array and we can check for every adjacent element whether my adjacent elements are equal or not. And if neither of the elements are equal, then my answer can be simply yes, because then the necklace could contain a distinct configuration of frequencies, otherwise my answer would be no. So in the above test cases, my vector would be 1, 2, 2 after sorting, and yes, these two are not equal, so it is correct, but these two become equal. So that's why my necklace becomes not beautiful, right? And for my second case, the vector array will look like 1, 2 and 3 after sorting, right? So 1, 2 and 3. So here I compare my adjacent elements since they are not equal, and even these elements are not equal. I can successfully say that this configuration is a unique configuration, and hence my answer to this particular case is yes. So yeah, in general, let me just summarize the entire thing. We can take a array. Firstly, we can just take a hash map and store the frequencies of each and every element. Then we can put those values of frequencies in a vector and we can sort the following vector. And then after sorting, we can just check for the adjacent positions. If any of the adjacent position is same, then that particular configuration is not unique, and hence answer will be no, otherwise my answer will be yes. Now let us see how we can code this particular approach. Okay, now let's try to understand the code for the following problem. So here I include all my necessary header files. Then in the main function, I simply input my t test cases. For each of the test case, I take my n as the input and then I initialize the map as I told in my approach section in order to take the frequencies. Then for the entire n, I take input as the variable and I increment the frequency of that particular element by 1, right? Then after computing this entire array, after computing this entire iteration, I have my frequency array ready. Then I simply create a vector v as I discussed in my approach section and I push all the frequencies of the values in that particular vector. And then I sort my vector, right? Then I initialize my flag as true, denoting that initially the sequence is true until we makes it false, right? So then we traverse in the vector and we check whether every adjacent element is equal or not. If any of the adjacent elements become equal in the sorted array, then that means that particular vector has repeated elements and hence the answer is false. And as soon as we get the answer as false, we can just simply see out no, right? Otherwise, if at the end of this iteration the flag is true, that means my entire array is valid and we can simply print yes. So let us run our code on the sample test cases to see whether everything is working correctly or not. So as you can see, we got the correct answer for the sample test cases. Now let me run on the code on the actual test cases to understand whether our code works properly or not. Okay, so as you can see, we got the correct answer for the following problem and yes, this becomes the valid approach. So now let me discuss what people could do wrong in this particular problem. So here the key observation was to compute the frequency array to take those values and check whether those values are distinct or not. And if this particular observation was clear, I don't think anywhere else a person could make mistake logically or syntactically in this particular problem. So yeah, this is the learning you get from this video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.